Howdy. Just gonna go over some of that stuff from Unit 4 and then some of the cycle stuff. With soil, I'm gonna go over it as it might pertain to the topics for the AP. I think the biggest thing with soil, it's not necessarily knowing or identifying each horizon. I think the biggest thing is that mixture and what the composition is and how that would affect how water and things can move through it. When I'm thinking about soil, I'm thinking about clay, silt, and sand mixed together. Remember that soil triangle. Um, Clay is not as permeable. Silt is the next largest, and then the biggest is sand. So the more sand that you have in that mixture, the more that things are going to be able to move through. So when we're talking about landfills and things like that, they're going to want to line it with something that is very heavy with clay, if not pure clay, and avoid things like sand or silt where the chemicals and heavy metals can leach through into the groundwater. Um, some other things about soil with conservation. So, the biggest thing that keeps soil in place is the actual trees and the roots and the vegetation that grow in it. This picture actually shows a good job. It really does anchor it throughout the top layers. So, the biggest thing to know is that when we clear a land of natural vegetation, we're taking that soil and we're loosening it up, and therefore it can cause the erosion into waterways that can cause increased turbidity. And then we're going to have a problem with light reaching down and those algae and organisms being able to photosynthesize. Soil definitely plays a role in that way. For keeping soil in place, for farmers, they can practice contour plowing. So basically, what they do is they would plant furrows. So we talked about furrow irrigation. This is like the same concept of the furrow where they're digging little grooves into the desired area and then they're planting in the grooves so that it prevents that wind from taking it. Windbreaks, putting really, really tall, dense trees or vegetation to prevent that wind from taking the soil. So a lot of farms will use that because it's really not that expensive. No till basically is when you're not going to plow the land. So you're basically going to continue to grow the crops without circulating your soil. When you bring up the soil and turn it, it's going to loosen it, and that's going to make it easier to run off. And then finally, cover crops. So basically, you can rotate the cash crops in order to blanket the soil all year. Just making sure that those nutrients continue to get back into the soil and making sure that the soil is covered with vegetation all year, because when it's barren is when you're going to have that increase of sedimentation. So that's some things about soil. If we talk about plate tectonics, moving up. So plate tectonics are really just the lithosphere floating on top of that mantle. So if you kind of think of like that mantle as this fluid layer, we're kind of at the mantle's mercy. So these plates are constantly in motion. What you need to really know are the different boundaries. So divergent, where it's pulling away, convergent, it's coming together, and at convergent boundaries, you're probably going to find uplifting mountain ranges and things like that. And then transform boundaries like the San Andreas Fault in California, that's going to be when the plates are sliding against each other. So when you have all of these boundaries, the constant motion is really going to affect the geography of where they are. Again, this is going to be where like you'll find the mid-Atlantic ridge is a big divergent boundary underneath the Atlantic Ocean. Convergent, if it's two land plates, you're going to find really, really, really high mountains. If it's underwater, you can find a seamount. And then you could also find volcanoes at those convergent boundaries. And then transforms are honestly very high risk for really big earthquakes because they have that tension that builds up. And if anything slips, that's when you get those massive earthquakes going on. Um, so basically the reason why they move is because, again, we're on this mantle, and the reason why they are moving is because of that convection motion underneath inside the mantle as it cools and it sinks down, and then it gets warmer, and then it rises again, and then it cools, and then it goes back up. So it's got that circular convection motion, which causes that moving of the plates. And you can kind of see with the arrows what it's causing here. This is a divergent boundary. All right, let's see. What else would plate tectonic? I mean, you can keep this kind of in the back of your head how oceanic plates are more dense and they go underneath the land plates when they collide, and that can cause a mountain range on the ocean. Um, I mean, that's definitely important, but I do think the basic understanding of each plate moving is key there. I think it's important to note that you know at least a couple of places in the world where you're going to find each of these. So again, Mid-Atlantic Ridge, you should be able to look at the map and point that out. Convergent, you should be able to find one place on Earth where there's a convergent boundary and transforms. So I think, is there a map on this one? No, there's not. So do yourself a favor, just Google some of these, go onto the AP website, take a look. There's plenty of examples. Just make sure, like geography, where that would be, just in case something like that comes up. All right. And then the cycles. I want to say maybe that's unit 1. Maybe. Maybe not. Maybe unit 2. Was it unit 1? I don't know. All right, how about this? I'm going to check this one more time, and then if not, I'm going to go to Google. Oh, here it is. All right, so it is unit 1. Now, this is important to note. So on this exam, you obviously don't have to memorize really most of this content. You just have to understand it and be able to apply it. So with nitrogen cycle, I think the hardest thing with that was understanding or memorizing each of these steps. It's really not about that anymore. It's about understanding what the point of these things are. So if we're looking at the cycles, I don't know where we're finding. Okay, this is pretty much the gist that you're going to want to know. So first, we'll take a look at the water cycle. The water cycle, it moves nutrients through the ecosystem through evaporation, condensation, precipitation. The largest reservoir for water, okay, are going to be the oceans. And also don't forget about glaciers. Okay, so think of all of these things, water in all of its forms and not just liquid. You're gonna probably, if anything, need to understand the importance of each of them. So importance to life. Well, the water cycle, okay, obviously plants use water for photosynthesis. Humans rely on water, okay, to survive. So you just need to make sure that you understand how it moves and what the importance is. Phosphorus, remember, phosphorus doesn't move through the atmosphere. It's only through land. The largest reservoir is sedimentary rocks. And if it does say, like, where is phosphorus important? In plants and animals, it makes up ATP. It's the P in ATP. It's also the backbone to DNA and RNA. So without phosphorus, we wouldn't be able to have life as we know it. So that is an essential nutrient for us to uptake into ourselves. Nitrogen, the largest reservoirs, is the atmosphere. The atmosphere has about 78% nitrogen, so it is the most prevalent gas. It's a really short life cycle, and it's very essential for plant life. So when we're talking about nitrates, okay, nitrates in the soil are essential for plants to grow. And that goes back to that office episode where Dwight's talking about, like, what do we need to grow plants? And he's like, phosphates and nitrates. Okay, so again, nitrates play a big role in all of different themes through apes. And I think the biggest thing is when we talk about nitrates, we often think about fertilizers, and fertilizers go onto soils to help plants grow. So just bring that all back to that cycle. The last cycle you need to know is the carbon cycle. A lot of carbon is stored in the oceans and the rainforest. Okay, and that is why when we burn down the rainforest, it actually re-releases that sequestered carbon back into the atmosphere. And that's what we're talking about when we're talking about increased carbon dioxide. Also, when we burn fossil fuels, it was sequestered under the ground in a carbon form such as oil, and then when we burn it, we're re-releasing that carbon back up that wasn't supposed to be released, and that's how we're adding to greenhouse gases, which in turn adds to climate change. So there's plenty of methods of transport. I think understanding photosynthesis and respiration on a basic level is super important, and I think we take it for granted in apes because we did learn it so much over the previous years. Make sure you do like brush up on these two basic processes. If you do not know the general equation for photosynthesis and respiration, that is some basic foundational information that could really just come in handy when you're trying to explain a long FRQ. Other than that, that's really what I have here. Some of the other things about, like, just things that I'm thinking of that can relate to the questions itself. When we think of soil, if they're asking about testing on soil, think about nitrates, phosphates, think about pH, okay, the pH of soil. Think about salinity of soil, okay, because salinization is a problem. That's when the salt builds up. So really, really, really understand the testing elements of soil. And again, if you are sitting there and you're thinking any of this, feel free to message me. I will bounce back and forth with you and brainstorm. But also, if we just look up like soil tests, if you look up soil test, you're going to scroll down and you're going to find a bunch of different applicable information. You might find that they sell soil testing kits at Lowe's. Okay, test and improve your soil, the pH, the nutrients. So all of these things can work into that question. And I think it's important for you guys to know that we don't just learn about it in apes and you'll never use it. This is stuff that you will think about and you will use if you ever want to grow a garden or want to start a fish tank or things like that. So definitely use Google and try to look for real life applications. If that's it, I'm going to leave it at that. I will have this posted on my Classroom and on the YouTube channel, and I'll put a link for both. And if you do have any questions, remember, hit me up on Remind. And over the weekend, anything, I'm here, I'm there, whatever time you need it. Okay, so just keep yourself motivated. If you need some words of encouragement, I got you for that too. Good luck. And if you need me to go over anything else before, just hit me up on Remind or send it on Classroom. Thanks. Have a good one.